Hi, this is Mrs. Ward, and today we're going to talk about ellipses. And we're going to write equations of ellipses in standard form, graph the ellipses, use property of ellipses to model and solve real-life problems, and finally find eccentricity of ellipses. So let's get started. First of all, the definition of ellipse. What is an ellipse? An ellipse is kind of an elongated circle, an oval, a squished circle, however you want to look at it. What the definition says is if I have 2 points, which I call foci, the distance from any one point to those two foci, when I add those distances, that sum is some constant number. When I have an ellipse, I'm going to have terms like major axes, minor axes, and then I'm going to have vertices. I'm going to have what I call major vertices and minor vertices. When I look at the formula sheet, it looks very complex. It is very similar to a circle. Some things that are similar to a circle is I am going to have the HK. HK is going to be still the center of my ellipse, just like it was the center of my circle. And H is going to be whatever I'm subtracting from X. The K is going to be whatever I'm subtracting from Y. What I do notice is it tells me that 0 is less than B, which is less than A. That's all great and good, but just know that A is your largest number. A is the largest number. That A will change places depending on how your ellipse looks. If your A is with the X, you have your major axis is horizontal, which means your ellipse will look longer from left to right. If your A is with the Y, your major axis is vertical, which means your ellipse will look elongated from north to south, up and down. The other thing on this formula sheet, which is extremely important, is this equation right here, which relates c squared is equal to a squared minus b squared. So you're going to refer back to this. You might want to highlight this. You might want to highlight this, and you already know the h and the k. I would definitely draw these pictures here if you haven't done that already. So let's get started. The first one, oh, before we get started, let me tell you about the terms here real quick. So if I have this ellipse, the point here is going to be the center. Then I'm going to have these 2 points which tell me how I'm drawing my ellipse, and those are called my foci. This purple line is going to be my major axis, and the reason why it's the major axis is because it's the longest axis. This green line is also an axis, but it's smaller, so that's going to be the minor axis. Then you have the points on the outside on the actual ellipse, which are on the major axes. Those are called my vertex or my vertices. I call these major vertices because they're on the major axes, but I also talk a lot about the minor vertices, which are going to be these 2 points here. And even though your book doesn't label them, they are kind of important on how you draw your graph and label your graph. So when I have this ellipse, and this one's going to have a major axis that goes this way. So I'm going to have my center. My foci have to be on the major axes. They can never be on the minor. They have to be on the major. The distance between my center and either one of these foci is going to be the letter C. The distance between my center and the major vertice is going to be the letter A. The distance from vertice to vertice is this is A, and then from here to here is another A, so the total distance will be 2A. And finally, the distance from my center to my minor vertice is going to be the letter B. So that's how I get the A, the B, and the C. Notice that A has to be the largest number. So let's do a problem. Finding the standard equation of an ellipse, I'm going to give you some information. It tells me that find the standard form of an ellipse having a foci at -2, 2, 4, 2, and a major axis of length 10. So I'm a visual, so I like to draw pictures. So I'm going to plot those 2 points that they give me, just a rough sketch. It doesn't have to be pretty. So here's one point -2, 2. Here's another point 4, 2. Well, as soon as I put those foci there, I know that my line of symmetry, my major axis has to go from left to right because the foci have to be on the major axes, which means that my A is going to go with my x coordinate. I also, from these two foci, I can figure out the center because the center has to be halfway between those 2 points. So I know the center is going to have a y coordinate because these both have a y coordinate too. So I know that. Then to find the x coordinate, I could do the middle of -2, 4. So find the halfway point or do the midpoint formula for those two. Or if you wanted to count, you could count. But my center is going to be 1, 2. It also tells me that the major axis has a length of 10. So from here, from one point to one point, that's going to be a length of 10, which means the distance from my center, which, oh, I didn't put in there yet, 1, 2. The distance between my center and that vertice would have to be half that 10, which means it has to be 5. So here's what I know just from that piece of information. I know my center is 1, 2. I know my A, the distance from my center to a vertice, a major vertice, is going to be 5. I can also figure out my C, which is the distance from my center to my foci, and I can count that, 1, 2, 3, 1, 2, 3, or I could have taken 4 minus 1, or -2 minus 1, and I would have gotten a distance of 3, because again, it's a distance that has to be a positive number. So now I can start writing my equation. So I'm looking at my formula sheet, and you will have that formula sheet for any test or quiz. I'm going to start with x minus, remember this is my h and my k, x minus 1 squared over a squared, so 5 squared, because we decided it has to go with the x coordinate, plus y minus 2 squared over, I'm going to write b squared because I haven't figured out b yet, is equal to 1 because every equation for an ellipse in standard form is always set equal to 1. So now I have to find b squared. So I'm going to go off and remember that formula that c squared is equal to a squared minus b squared. That was on my formula sheet. So 3 squared is equal to 5 squared minus b squared. So 9 is equal to 25 minus b squared. The opposite of b squared is equal to -16, so b squared is equal to 16, which means that b is equal to 4. So substituting 4 back in for this b, I'm going to substitute 4 in there. So I'm going to have x minus 1 squared, and then 5 squared is 25, plus y minus 2 squared, and then 4 squared is 16 is equal to 1. And that is my equation of that ellipse with those given properties in standard form. Okay, doing the next one. It wants me to sketch the ellipse x squared plus 9y squared is equal to 225. So again, referring to my formula sheet, I know that everything is equal to 1, so I'm going to divide by 225. Whatever this number is, I want it to be 1, so I'm going to divide by that number. So I'm going to start with x squared over 225 plus 9y squared over 225 is equal to 1. This x squared over 225 I'm going to leave. To simplify this 9y squared over 225, I can either put 9 over 225 in my calculator, and it will give me 1 over, oh, I had it written down here. I'm either going to put that in my calculator and do 9 over 225, and it'll give me a fraction of 1/25, or I can divide 225 by 9. Either way, I'm going to get y squared, I don't know why my pen stopped working, y squared over 25 is equal to 1. So identify my center. Well, I'm not subtracting anything from my x, and I'm not subtracting anything from my y. So my center is going to be 0, 0. I have two graphs here. Let me just get one of those out of the way. So my center is going to be 0, 0. So I'm going to plot that. 0, 0. Then I'm going to take this, the larger of the 225 and the 25, the larger of those two numbers is the 225. So I'm going to take the square root. So that means a squared is equal to 225, taking the square root, a is going to equal 15, and then b squared will equal 25. So take the square root, so b is equal to 5. So I plot my center at 0, 0. My a is 15. My a goes with my x, which means I'm going to go 15 to the left and 15 to the right. So I'm going to make each one of these 2. So this will be 2 and 4 and so on. So that'll be 15 to the left, right, 15 to the left. So those are my major vertices. And then my B will be 5. So 2, 4, 5. 2, 4, 5. So I had to make each one 2 to fit my graph on here. And that is my sketch of my ellipse. Oh, it wants me to identify the vertices too, so I should probably write those down. My center is 0, 0. To find my vertices, to find this vertex and this vertex and this vertex, I added my 15 to the x coordinate. So it's kind of like I took that 0 and I did plus or minus 15 because I'm changing x to 0. So I ended up with 15, 0 and negative 15, 0. To find the minor vertices, I'm going to take the center, which is 0, 0. But this time to find the minor vertices, 0, I'm going to add and subtract that 5 to the y coordinate. I'm going to end up with 0, 5 and 0, negative 5. And those are my minor. Those are my minor vertices. And these were my major vertices. And that's my graph. That's my graph, and that's my labeling of my center and my vertices. It does not ask me for the foci, so I'm not going to go ahead and find that. I'm just going to move on. So looking at the next one, you want to find the center, vertices, and foci of an ellipse given by the equation. So this one is going to be one where we have to complete the square, just like we had to complete the square for a circle. And we are going to put all the x coordinates together, and we're going to put all the y coordinates together, and then we're going to put anything that doesn't have an x or y on the other side. So I'm going to write 9x squared plus 18x plus 49y squared minus 294y, and putting the 9 over the other side will equal negative 9. Then I'm going to complete the square. You'll notice that the difference between a circle and an ellipse is these coefficients are no longer the same. If they were the same, it would be a circle, and I would divide everything by whatever that coefficient is. But because they are not the same, I'm going to have to complete the square with both the 9 and the 49. I'm going to have to factor them out. So let me show you exactly how I would do that as slowly as I possibly can. So here I have a 9x squared. I'm going to factor out that 9, but I'm only going to factor it out from the x terms. So I'm going to write 9. Factoring that out, I'm going to have x squared plus 2x, because 18 divided by 9 is that 2. I like to write a plus and leave a blank, just to remind me what I'm doing. Then I'm going to do the same thing with the 49. I'm going to factor out a 49 from just the y term. So I'm going to write plus 49 y squared, and then 294 divided by 9 is 6. So this will be minus 6y. Again, I'm going to write plus and leave a blank. And this negative 9 hasn't changed at all, so it's just going to stay there. Now I'm going to complete the square just like I did before with one extra little step, and it's really not that big of a step. I'm going to copy this 9 down. X, whatever this sign is, this is a plus sign. I'm going to write a plus sign. Half of 2 is 1, so I'm going to write a 1 here. 1 squared is 1. So in order to have x plus 1 squared to be x squared plus 2x plus 1, I have to add a 1 here. But I'm not really adding just a 1. I'm really adding a 9 times that 1. So to this side, I really added a 9. So if I added 9 to this side, that means on the other side, I'm going to have to add a 9. Now let's do the y's. Same thing. I'm just going to copy down that 49. It has to come down with me. Y, this is a minus sign, so I'm going to copy down the minus sign. Half of 6 is 3. 3 squared is 9, so I'm going to put a 9 here. But again, I'm not really adding 9 to that side. I'm adding 49 times that 9. So when I take on my calculator 40 times 9, I get 441. So I'm really adding 441 to this side because I really added 441 here. That's what that 49 times 9 is. So when I look at the right side and I add these all up, well, those equal 0, so I'm going to end up with 441. It's an ellipse, so it has to be set equal to 0. So what I'm going to do is I'm going to divide both sides by that 441. Well, actually, I'm dividing everything by 441. So I'm going to take the time to show them dividing everything by 441. When I do that, let's just get that out of the way. When I do that, I can either put 9 over 441 in my calculator, or I can divide 441 by 9. Either way, when I do that, I get x plus 1 squared, and this will be over 49, plus dividing both of these by 49, or putting 49 over 441 in my calculator, I'm going to end up with y minus 3 squared over 9, and this is equal to 1. So this is my equation of my ellipse in standard form. Let's write down some things that I know. I know my center is going to be the ordered pair -1, 3. I know my a is a larger number, so my a squared is going to be equal to 49, which means a is equal to 7. I know my b is the smaller of these two numbers, so b squared is equal to 9, which means b is equal to 3. I'm going to plot what I have so far. Let's see if I can bring out this graph paper. So I'm going to plot the center, which is -1, 3. Then my x is going to move to the left and the right 7. So I can sit here and count 1, 2, 3, 4, 5, 6, 7, and go 7 the other way. And I can write those vertices. If I did not want to count, what I would do is I would take this -1 and I would add and subtract the a, which is 7. My x coordinate would stay the same. So -1 plus 7 would be 6. So my one ordered vertex would be 6, 3. The other one would be -1 minus 7, which would be -8, 3. So those are my major vertices. Now to do my minor vertices, my b was 3, so that means I'm going to go up and down 3. 1, 2, 3. 1, 2, 3. So if I go to my center again, the x coordinate is not changing in this time. I'm going to do 3 plus or minus my b, which is 3, happens to be the same number. So I'm going to have -1, and then 3 plus 3 is 6. And then -1, and then 3 minus 3 would be 0. So those are my minor vertices. That's an R. And this is a sketch of my ellipse connecting those vertices. I'm going to go up and make sure I haven't missed anything. I gave the center, I gave the vertices. Oops, I did not do the foci, so let's go down real quick and do the foci. So the foci is my C. So I'm going to remember that C squared is equal to A squared minus B squared. So I'm just going to go here to A squared and B squared since I already have them squared. So I'm going to say c squared is equal to 49 minus 9. So c squared is equal to 40. So again, my foci have to fall on this line of symmetry on the major axis. So they have to be somewhere on this line. So it's the x-coordinate that's changing. So, well, I forgot to tell you that c is equal to square root of 40. So I'm taking my center, which is negative 1, 3, and I'm going to add and subtract the square root of 40 to the x-coordinate. So I'm going to have negative 1 plus or minus the square root of 40, and then my y-coordinate will be 3. And I can leave it like that because I cannot simplify. I can simplify the square root of 40, but I can't combine the negative 1 with the square root of 40, so I can leave it like that. For those of you who like simplifying radicals, you would have 1 plus or minus 2 times the square root of 10, 3. But again, this is perfectly fine if you leave it as square root of 40. So that is my foci. Okay, looking at the next one. You want to find the center, vertices, and foci, the same thing that we just did on the last one. So I'm going to give you a second to pause the video and try and do it on your own, and we'll see if we match at the end. Okay, I hope you had some luck with this. So what I did, I'll just talk through it real quickly, and hopefully you had the same thing that I do. I took my x's and I put them together. So I did 16 and 32 x, put those two together. 25y squared and minus 50y, put those two together. Took 16 onto the other side. Factored out the 16 from both the 16 and the 32. That's how I got the 1 and the 2. Factored out the 25 from the 25 and 50. That's how I got 1 and 2. Completed the square here, brought the 16 down. Half of 2 is 1. 1 squared is 1. 16 times 1 is 16. That's why I add 16 to this side. Here I took half of 2 and got 1. 25 and 1 squared is 1. 25 times 1 is 25. When I added these three numbers up, I end up with 25. I'm going to divide everything by whatever this number is. So I divide all three terms by 25. When I did that, I ended up with 25 sixteenths and 1 for my denominators. This I divided both the numerator and the denominator by 16, and that's how I ended up with that 25 sixteenths. My center is going to be 1, 1. Between the 25 sixteenths and the 1, the 25 sixteenths is larger, so that becomes my A. So A squared is 25 sixteenths. The A then becomes 5/4. B squared is 1, which means B is also equal to 1. Then I plotted my points, and I made each line worth 1/4 so you could see what I was doing. I know my ellipse isn't very neat, but best I can do on this thing. My major vertices, I'm adding that 25 sixteenths to my x, so I took 1 plus or minus that 5/4, end up with 9/4 and negative 1/4 for my new x coordinates. My excuse me, my minor vertices, I added and subtracted 1 to my y coordinate, and I got 2 and 0. So those are my minor vertices. To find my foci, I took c squared is equal to a squared minus b squared. Got 9/16, and again you can do that on your calculator. Took the square root and ended up with 3/4. The foci have to be on that major axis, which means it's going to change the x coordinate of my center. So I added and subtracted that 3/4 from my x coordinate of 1, and I ended up with 7/4 and 1/4. So hopefully you got the same thing. So now the last thing we're going to talk about is eccentricity. All eccentricity is it tells me how elliptical my ellipse is. In other words, how much the ovalness of an ellipse, I guess is the best way to say it. Very simple formula. Eccentricity is just equal to C over A. That's all there is to it. So if I go back to, well, let me say this first. The smaller E, the closer I am to 0, the closer my eccentricity is to 0, that means the closer my foci are to the center, which means it's going to look more circular. The closer my eccentricity is to 1, that means the further away my foci is from the center, which means it's going to be more elliptical. So if I go back to this last problem that we just did, whoopsie, not that one. I go back to example 4, and I want to find the eccentricity. Going here, my eccentricity is going to be E is equal to C over A. In this case, my C was 3/4. My A was, I believe, 5/4. 5/4. So I'm going to divide this by 5/4. Again, I'm going to do that on a calculator, or I can do it mentally, and I end up with 3/5, and that's my eccentricity. And that's approximately 0.6, which means it's pretty much, it's not really close to 0. It's a little bit closer to 1. It's more than 1/2, so it's more elliptical than circular. So I hope this helps. We will do, if you don't, you can work on the classwork problems, and if you have any questions, I'll answer those in class next time I see you.